We're going to talk about the different era types. And the first type of era that we're going to discuss is the syntax era. And to look at this, I'm going to go look at one of our past exercises from chapter 4. And I'm just going to open it. And I know this is a working, running exercise that we already completed, but I'm gonna add a syntax error to it right after we default choice as y. We're gonna say pig equals cow plus 7. So we basically just put some nonsense in there, and when we run this nonsense, we get a syntax error. This Python pops into the main over here and goes, "Hey, pig equals cow plus 7. I have no idea what that is. Cow is not defined," and it gives us a syntax error. And syntax errors are probably the easiest to find because you don't even compile. You try to run, it tries to compile it, and says, It flags it down and gives a fairly decent job at telling you what's wrong. Now I'm going to introduce a runtime error. A little harder to find, so we're gonna go over here, and at the top we're importing some functions in this module, and we're gonna hide from Python where it is, so it's not gonna know that it's in the module val. We're just gonna leave it like that. We're gonna run it, and it compiles and everything, so we don't have a syntax error. And we're going to put a monthly investment in and a rate of 7%, and then boom, it hits the line of code here and says name get int is not defined, and indeed it is not defined. It's within this particular module. It's getting imported from validation, which we aliased as val, and it cannot see that. To fix that, runtime, we can put val back in there. We can run module, and let's do 200 a month, rate of 7%. And now it's popping up for 20 years. This is nice. Now we fixed the runtime error. So we discussed syntax errors, which you get as you compile. Most obvious kind of errors. Runtime errors that you're going to get sometime in the run of your program. And the other type of error is logic error. That's when something's wrong with your program, and it's a little harder to find because it doesn't crash. It doesn't tell you anything is wrong. You just maybe did a calculation incorrectly. Like, for instance, let's say, and this is kind of an obvious one, but let's say we have the calculation wrong here. Let's go up 0.01. It runs, goes here, we go, well, we're going to put 200 a month. 7 for 20 years. And we actually get another another runtime error due to where we got a integer and float mix. So let's do something else here. Okay, so we inadvertently made a runtime error. So we're gonna do like this. We're just gonna times it by 1. It's like a bonus there. We got 2 runtime errors on that one. So we're going to go monthly of 200 at 7 in number of years. Let's go for 20 years. And we calculated it, but we have a few things off, and our value is because of that is calculated incorrectly. So in a logic error, everything works out, no red flashing lights errors, when you compile, none during the runtime. Everything goes smoothly, it just doesn't work correctly. And this is the case here, that the interest over 20 years is not working. Over here it should be months equals years times 12. We have times 1, and we ruined our calculation. And runtime errors and syntax errors you can find easy, but these logic errors are very hard to locate. One of the tools that people use to try to track down these type of issues is the debugger. And I'm gonna give me a sample of that, and to kind of start going into it, you can set a breakpoint. What this does is going to let us, instead of when we run the program, it fluidly goes through the code until we give it a stopping point, like we ask for input or something. But with the debugger, it's going to let us put what we call a breakpoint, a place to run through the program and break when we get here. So we put over this calculation. So let's run this. And what we're going to do is we're going to run it here in, I'm going to restart shell and go to debugger. And let me get this set up before we run. I always like to set everything so it just basically keeps track of everything we need to keep track of. And we're going to try that again. So run module. Okay, now that we have the debugger up, you notice a few things. It's keeping track of some of the globals we have out there, and we can see some of the things assigned. So we're going to step through this. Oh, it's going to take a while. Let's go to go. That should just jump it right through all the way to here, the first input. So we're going to go 200. We're going to go 7 number of years. Remember where we put our breakpoint. So theoretically, once it hits that breakpoint, we should get there. So we're going to say 20 years. Bingo. It stops on that breakpoint. And it still has all the globals, which kind of you see the name of it, the double underscore main, double underscore, the modulus in. But what might be of more interest to you is these locals, because these are things locally here that you have defined. We have yearly interest, we have years, and we have monthly investment. So it's showing some of the values, and at here's where we think we did wrong. So we're going to step through it, and you notice when we step through it, it set the months, and you can see that it set it incorrectly. And so this is the real benefit of the debugger in Python and in idle. It's not the best debugger, and personally, I really only use it if I'm on a real bind on usually a larger program than this, and I'm stepping through everything and I go, man, my calculations are wrong. What the heck is going on here? And I can look here and I can see how things get set. And so it kind of lets you see what's going on, and you can slowly step through a program. This one was obvious to us because we intentionally made the error. But if you had a more complex program, and maybe 20 or 30 of these, and you're walking through to see where it went wrong, you could basically step through by hitting the step, and you could see via doing that where you went wrong, and see how that's one by one. It's just stepping through the program, and I hit go if I really wanted to just fly, and I did. And we're gonna say we're just gonna exit it, and that's what the debugger gives you. It gives you the ability to see in your variables within your idle session, which is really useful. Like I said, with really big programs, and in times when you're making some calculation and you're at your wit's end, you can't see where this error has occurred. Like I said, I personally don't use it very much unless it's a really large program that I can't. And I eyeballed the program. I went down line for line, and I'm like, man, I cannot see what went wrong and why. And I could slowly step through, and I could see each step, and I could see the different variables, the local variables, as they get assigned. And great way if you have a large program with a lot of variables and you're really not sure what's going on. This is not the easiest debugger to use. I think the text mentions that once or twice. It is pretty Spartan, but it gives you really what you need, the ability to be able to step through and then also see how everything is assigned. So it is kind of Spartan, and it's not too intuitive running it, having to set a breakpoint first and then pop up the debugger and then rerun your program. But it does the trick.